my name is Yuewen Zheng, and today I want to show you my work of how to deal with streaming data. Oh, okay. Okay, so as we know, our world is inundated with a bunch of sensors. So what is sensor? Sensor is a device that can detect the changes and events in its environment, and later will provide the corresponding output. So we have different sensor devices can monitor environmental conditions, traffic flows, even record and transmit live videos, feeds over the internet to big data stores, and later can be analyzed by different use cases. But sometimes we may want to use this sensor data like immediately. The question is how. So we need to have a system that can aggregate and analyze, also use these streams in real time to make sure we can use these insights of data and translate it to action like real fast. We are now building a real-time streaming analytical system and also leveraging several platforms such as Apache Kafka, NiFi, Flink, and Avro to build a complete end-to-end system that can use hierarchical and online machine learning models to predict and control the whole system at different level of granularities. Let me show you more about how we build and use these hierarchical and online machine learning models. So first, we can get the insights of data from different sensors. And later, we will have the first level monitor and control by using room-based models. And also the second level with floor-based models. In the end, we will have building-based models. Also, the higher-level models can direct and amend the lower-level ones, so to make sure we have a better control of the whole building. And also, our system is complete, distributed, and scalable for thousands of sensors from different use cases. Let me give you a real use case of what we are doing now. We are now deploying and evaluating the stream data from embedded platforms and sensors such as Raspberry Pis, Intel Edisons, in the CP building of UW Tacoma to collect data such as humanity, such as light and images and also video stream. Later, this data will feed into our server prediction system. So we can also have simulated controls, and those things can later show us some facts, like how we can improve the whole building energy efficiency, as well as how we can provide visibility to our building security system. So how the stream data processed in our system? First, we need to know what is Kafka. Kafka is an open source message broker. We have different producers, and they can send in messages to different topics. Later, consumers can read the data from topics as they want. So Flink has a core of streaming data flow engine, and also different jobs of Flink consume the data from Kafka. Also, the job range from simple data transformation to more complex application as machine learning. Also, NiFi can provide us a powerful and scalable directed graph that can show the data routing. So we can have a better sense if we can see the whole workflow. Okay, our ultimate goal is to make UW Tacoma building smart, self-learning, adjusting light temperature to save energy, also can balancing the fresh air proportion, CO2 levels to improve study environment and avoid disease. And it's quite important because if your physical fueling sucks in your classroom, it will ruin your study performance quite badly. Also, it can provide others when emergencies and accidents such as break-ins, fires, etc. In the future, we also want to expand the scope of our system to smart manufacturing, agriculture, and field work researches. So if you want to do the streaming data easier with a low cost, choose our system. It's quite smart. Thanks.